So some kind of the background and motivational stuff behind SLATE is all about this idea of supporting scientific collaborations over multiple institutions. And so kind of our fundamental motivation here is that it's been our observation that building a distributed computing facility is really challenging. If you want to set out and build a US Atlas computing facility or something similar from scratch, right? There's a lot of people that you're going to have to deal with, a lot of personalities to deal with. There's also a lot of sort of administrative domains in the sense of dealing with different institutions and their own policies and their own institutional idiosyncrasies and all that stuff. And then once you've got everybody to kind of agree to build a thing, you still have to, sort of technically implement it and deal with all of the interesting and diverse technology stacks that folks are running at their sites. And somehow you have to glue all that together. And so supposing you did all that and you put it together, maintaining the thing is actually even harder because now you have to think about how you're going to coordinate updates across all your sites. Your application developers of the software for your collaboration have to think about how they're going to maintain compatibility across a large range of software versions. So, in my little picture here, I have, you have all these sites and they're running different versions of the data lake. And one of them may be really out of date, one of them may be really new, that sort of thing. And so the APIs have to be really stable. And that can be a difficult thing. And, as these things start to mature, introducing new software starts to become difficult as sites, get sort of stagnant, or rather, mature in their operations. And so it can be difficult to do that. And then lastly, monitoring the whole thing and kind of keeping the plane flying is a really difficult thing to do. And we have a hard enough job as it is, but we think that especially with the HLHC era and all the things that come with that, it's only going to make things more difficult. So we started to think about what is it that we could try to do to make running our computing facility easier in the future. And so the first thing that we thought about was that it would be really nice if we could take our sites that today are providing endpoints like, storage elements and compute elements, and we try to extend that model, especially with the Science DMZ, to include a new kind of endpoint that would be for running along those services. And we wanted to build something that would be sort of open and secure and ultimately let us be able to launch services at other sites in a kind of secure and trusted way. And sort of the thing that immediately followed that is that it would be it would be dangerous to have this be sort of a wild west of just letting people come in and run whatever service they want. And so it was very important to us to try to address that. And so we thought hard about this, and what we came up with is that ultimately what we need is a catalog of applications. And those applications are sort of things that are well understood in our community, and those things are reviewed by the people maintaining the catalog, and those get deployed out the sites. And ultimately what we want to do is make it possible to deploy services at sites, but then also give sites the ability to have this fine-grained control over who does the deployment of what at their site. And we wanted those things to be very specific as they could be. And then with those other two things in place, we felt that what we could do, what that would enable, is that we could then sort of reorganize how we approach running services and deploying software at our sites by trying to reorganize ourselves into teams that would run particular things for particular sites. So for example, you could have a squid team or an Xcache team, and those people would be responsible for running those applications for sort of the whole collaboration. Likewise, you could have somebody running, the compute elements. Maybe someday you could have somebody running the storage elements if the platform was powerful enough and stuff to do that. And so we went out and we attempted to build this based on sort of that conceptual backing. And so we came up with SLATE, which you've all heard about, but just as a reminder, it stands for Services Layer at the Edge. And this is a service deployment platform that we've put together that is based on Kubernetes, largely to take advantage of a lot of the momentum that's happening out there in industry right now. We added sort of our own custom layer on top of Kubernetes that allows for federating sites together. And we have sort of a central platform where you can do that. And it has sort of a vaguely Unix-like permission system. And we'll see a little bit more about that. And then the other piece that we created was sort of this application catalog, much like how OSG packages various bits of software that are useful for our community. We sort of taken that to its logical extension and taken containers of services that OSG and CERN and others have built and tried to create a catalog of these applications that are in kind of well-known states and can be looked at and people can understand how exactly was this put together and all that stuff. And so we wanted to make this really easy to hack on. We wanted to make it really simple to deploy these things. And so we've put all this together. And as I mentioned before, you can kind of think of this as a service element, for lack of a better term, in addition to the compute elements and storage elements that you have today. So some examples of this model, not necessarily using SLATE, but conceptually the same thing, is building out something like a content delivery network. So you can tell these slides have been reused for other presentations, but in Atlas we're of course using SLATE to deploy Xcache, at least at some of our sites, to do our extra deep based data caching. OSG is doing something very similar. They're running what they call stash cache, which is just sort of another configuration of Xcache. The OSG has deployed this, sort of with the traditional method. It's available in SLATE, and it's also been deployed on the Pacific Research Platform, which is another sort of one of these Kubernetes-based deployment platforms. So this is an example of like how do you deploy Xcache on a site with SLATE. Over here on the right, you have this YAML file that basically describes how a SLATE application looks. So kind of here in the middle, if you can see my cursor, it's got this Xcache config bit. And that's just saying, okay, Xcache, please look at these directories for where you're going to store data. Here's where you put your metadata. Here's your high and low watermarks and other various parameters that get fed into XRD. You have a field here for putting secrets into place. So this is basically an X509 certificate. You have some other interesting stuff here, like this service will start up and with some special sauce, automatically register itself with Aegis. Has some stuff to describe where the service is running and on what port, that sort of thing. And then over here on the left, you can see, there's this upload certificate step. So this is where you take a secret like a X509 credential and you upload it into SLATE. SLATE stores that sort of encrypted at rest. And then it makes a copy of that goes onto your target cluster. You can then ask SLATE to deploy your app, and you tell it under what group it wants to be, you want to deploy it, what cluster you want, where you want to deploy it, its configuration, that's this thing over here. And then it will just go out and pull the containers that's appropriate, apply the configuration to it, and start up the service and do all the stuff that's baked into that container. Deleting it is pretty simple. You just give it an instance ID and tell SLATE to delete it, and it will go and take care of all the Kubernetes stuff that needs to be done to clean that up. And then you just sort of test it in the usual way with good old XRDCP. And you can see in this particular case, we're pulling from a cache that's running inside of ESNet, and then that's reading data from Midwestern 2. Another example of this federated operations concept are job gateways. So, in Atlas, what we're doing is using SLATE to do some of our integration work with Frontera at TAC. So right now we have basically our MariaDB database that stores all the stateful information for Harvester living inside of SLATE. And our plan is to essentially move the Harvester service inside of SLATE as well. So we sent a SLATE machine down to TAC, and it lives essentially adjacent to Frontera. And it's kind of nice because we have some control over the long-lived service that runs there. We don't have to make this, a TMUX session on the login node or a cron job or whatever. We have sort of full control to run our service there. Likewise, CMS is very interested in using the SLATE infrastructure that we've set up there. And so their plan is to essentially run an OSG compute element so they can send CMS glide-ins to Frontera. Lastly, SLATE is not built to just run existing stuff. We're really hoping to make this idea of a substrate for running services be sort of ubiquitous. And so when the next thing that comes along, right, when we're done with Xcache and we want to build Ycache and Zcache, or we want to build some other kind of crazy new application, it can be done in such a way that developers sort of target SLATE or target containers and Kubernetes as their platform upon which they want to run their software. And then we'll already have all of these sites out here with SLATE. And so to deploy their application at a site, it'll just be, they go to the admins of the site and they say, we have this fancy new application and we'd like you to do a SLATE, app allow or group allow or whatever for this new thing that we want to run at your site. And we're hoping that is ultimately where SLATE will go.